In the tech industry, every year brings new trends, buzzwords, and revolutionary ideas that promise to change the landscape of our digital lives. From NFTs and blockchains to metaverses, the tech world is never short on hype. Now, the latest trend that has caught everyone's attention is the rise of NPUs, or neural processing units. With every major tech company touting the capabilities of on-device AI, whether it's Apple's Intelligence, Google's AI advancements, or Microsoft's Recall, it seems that NPUs are suddenly everywhere and poised to be the next big thing. But this leads to an important question. Are NPUs genuinely the real deal, or are they just another example of Silicon Valley snake oil, destined to fizzle out like so many tech trends before them? What are NPUs? To understand the role of NPUs, let's first take a closer look at the modern high-end chip architecture. A perfect example is Apple's M3 Max chip. This chip, like others in its category, is a system-on-a-chip (SoC), which means it packs a variety of processors into a single package. This includes the CPU, Central Processing Unit, the GPU, Graphics Processing Unit, display controllers, I/O controllers, and, of course, the NPU. At first glance, the NPU on the M3 Max is surprisingly small, especially considering all the hype surrounding it. In fact, on the M3 Max chip, even mundane components like display engines and I/O controllers take up about 5 times as much space as the neural engine. However, as the chips get smaller, such as in the A17 Pro used in iPhones, the NPU's proportionate size increases, indicating its growing importance in smaller, mobile devices. This allocation of chip real estate highlights an important trade-off in chip design. Companies like AMD, under pressure from partners like Microsoft, are being pushed to prioritize NPUs over other components, such as additional CPU cores. In other words, while NPUs are growing in significance, they are still relatively small parts of our chips, though they are becoming increasingly prioritized in smaller devices. Why NPUs matter: the concept of accelerators. To understand why NPUs are becoming more important, it's crucial to understand the concept of accelerators in computing. Essentially, your computer is a machine designed to perform mathematical calculations. Every image, sound, and piece of text is represented as a series of numbers, which the computer processes through mathematical operations. In the early days of computing, all these calculations were performed by the CPU, a general-purpose processor designed to handle a wide variety of tasks with high precision. However, computer scientists soon realized that many tasks didn't require the CPU's level of precision or flexibility. For example, rendering graphics on a 4K display requires updating roughly 8 million pixels 60 times per second, amounting to around 500 million pixel updates per second. The math for these updates is simple, but performing them at such a high rate is a significant challenge. This is where the GPU comes in. Unlike the CPU, which is designed for flexibility, the GPU is optimized for parallel processing, allowing it to perform many simple calculations simultaneously. This makes it ideal for tasks like graphics rendering, where speed and efficiency are more important than flexibility. Beyond GPUs, there are many other types of accelerators, such as video encoders/decoders and image signal processors, all designed to handle specific types of calculations more efficiently than a general-purpose CPU could. NPUs are the latest addition to this family of accelerators, designed specifically for handling the math behind neural networks. The role of NPUs in modern devices. Neural networks have been used for years, especially in mobile devices, to power features like autocomplete, image recognition, face detection, and more. These networks are essentially mathematical models that, through a process called training, learn to recognize patterns and make predictions. For example, a neural network might be trained to recognize whether a series of pixels in an image form a diagonal line. In a simple neural network, you have layers of neurons, essentially memory cells that store numbers, connected by weights, specific numbers that define the strength of each connection. When an image is input into the network, the neurons in the input layer are activated based on the pixel values, and these activations are passed through the network, with each connection's weight modifying the signal. The final output layer then gives a prediction based on the input image. This process, known as multiply accumulate (MAC), is at the heart of neural network calculations. It's a relatively simple operation, but when you're dealing with a neural network that has billions of parameters, the number of MAC operations required can be astronomical. This is where NPUs come into play. NPUs are designed to perform MAC operations extremely efficiently. They have multiple small compute units working in parallel, a large amount of memory to store the neural network model, and specialized caches to quickly store and retrieve data. Additionally, NPUs can operate at lower precision levels, which is often sufficient for neural network tasks, allowing them to process calculations even faster. NPUs versus GPUs. What's the difference? Given that NPUs and GPUs both handle parallel processing tasks, you might wonder what the difference is between them. The answer lies in their optimization. While GPUs are designed for peak performance, capable of handling the most demanding tasks like real-time graphics rendering or complex simulations, NPUs are optimized for power efficiency. They are designed to handle neural network tasks continuously, without consuming much power or requiring the main CPU or GPU to be activated. This focus on power efficiency is why NPUs first gained popularity in mobile devices. Smartphones and wearables, which need to run tasks like heart rate monitoring or crash detection in the background without draining the battery, benefit greatly from the low power consumption of NPUs. On the other hand, PCs, which have traditionally prioritized peak performance, are only now starting to incorporate NPUs as their use cases expand. The future of NPUs, promising use cases. So, what does the future hold for NPUs? While current applications like image generation or chatbot interactions are often cited as examples of NPU capabilities, these tasks can typically be handled just as well by GPUs. Instead, the real potential of NPUs lies in more subtle, continuous tasks that run in the background, enhancing the user experience without drawing attention to themselves. For example, real-time captioning and translation of audio on a computer, or features like Windows Studio Effects, which can blur backgrounds and isolate voices during video calls, are promising candidates for NPU optimization. These tasks require constant, low-power processing, making NPUs an ideal solution. Perhaps the most compelling use case for NPUs is in systems like Microsoft's Recall, which continuously captures and analyzes everything you do on your computer. By taking screenshots, running image recognition, and creating a searchable database in real time, all while running quietly in the background, Recall exemplifies the type of task that NPUs are exceptionally suited for. This kind of continuous, complex processing would be impractical without the power efficiency of an NPU. However, the adoption of such systems raises important questions. Will users accept the intrusive nature of constant monitoring, or will developers come up with other innovative uses for NPUs? The answers to these questions will determine whether NPUs become a staple of future computing or fade into obscurity. Conclusion: the NPU's role in the tech landscape. As we've seen, NPUs are neither a miracle solution nor mere hype. They represent a significant advancement in the ongoing quest for more efficient, specialized computing hardware. While GPUs will likely remain the go-to choice for peak performance tasks, NPUs offer a valuable complement, especially in devices where power efficiency is paramount. Whether NPUs will become as ubiquitous and essential as GPUs remains to be seen. Their success will depend on the development of new applications that can fully leverage their unique capabilities. In the meantime, NPUs are already proving their worth in mobile devices and are beginning to find their place in the broader computing landscape. As the tech industry continues to evolve, NPUs may well become a key component of the next generation of devices, enabling more intelligent, responsive, and efficient computing experiences. Whether you're a tech enthusiast or a casual user, it's worth keeping an eye on this emerging technology and considering how it might impact the devices you use every day.